Welcome to qnawire.
So here it's a little bit tricky in the sense that we have to define two components for the police car. So we are going to define the origin to be the location where the speeder directly passes the police car. So we're going to, again, start a timer at the instant that the speeder passes the police car. And after 8 seconds, we find that the police car then reaches up to the speeder. So for the speeder, the speeder's at a constant speed, with a constant velocity in this case. So we can say that the total displacement of the speeder at delta x sub s would be equal to the constant velocity of the speeder times t. And this would simply be equal to 8.00 times velocity of the speeder. And again, the units here would be meters. For the police car, we have two components. So first, the policeman in the car has to react, and then it has to reach up to the speeder. So we can say that the first second is just the policeman reacting. So we can say that delta x for the police would be equal to the velocity of the police times 1.0 seconds. That would simply be the reaction time. So this would be 95 kilometers per hour multiplied by 1 meter per second divided by 3.6 kilometers per hour, and again multiplied by 1 second. And this would equal 26.39 meters. Now the second part of the police car, we can say that, the second part of the police car's displacement would be, we can say, delta x of the police car sub 2, and this would equal velocity, the initial velocity of the police car times 7.0 seconds, so the rest of the 8 seconds, plus 1/2 times the acceleration of the police car, which is constant, times 7.00 seconds squared. And so this is going to equal 26.39 meters per second multiplied by 7.00 seconds plus 1/2 times 2.00 meters per second squared multiplied by 7.00 seconds quantity squared. And this is going to be equal to 233.73 meters. So here, the total displacement of the police car would be equal to 26.39 plus 233.73. This is equaling 260.12 meters. Now, we're going to set the two displacements equal to one another so we can solve for the speeder's velocity. So we can say that 8.00 times the velocity of the speeder should equal 260.12 meters. And this is how we're going to find the velocity of the speeder. This is going to be 260.12 meters divided by 8.00 seconds. This is going to equal 32.5 meters per second. We can convert, so 3.6 kilometers per hour for every 1 meter per second. And we find that the final velocity of the speeder is approximately 117 kilometers per hour. This is our final answer. That is the end of the solution. Thank you for watching.